Welcome back, everyone. We're going to do the last section that is going to be addressed in Chapter 7, and that's going to be Section 7.3 on solving systems of linear equations. And for this one here, we're going to look at the third and final method of doing this, which is the method of addition, or what is also sometimes known as elimination. And why it's called that will become clear when we do the first problem here. The first two methods we looked at in 7.1 were solving systems by graphing and finding their intersection point. And the second method we looked at in section 7.2 was by the method of substitution. There's something very satisfying about doing the elimination method to see two large equations combined together to one equation and have one of those variables go away. Now, when we first introduced this, the first set of problems work out to be quite nice because things cancel very nicely on their own. Typically, and the kind of problems that you would expect to see like on a final, that's not going to be the case, and then we'll have to do a little manipulation. But we'll go ahead and cross that bridge when we get to it. So in this system, we have the following two equations, which I'll go ahead and rewrite here. We have 6x plus 5y is equal to negative 3. And the other one's going to be 5x minus 5y equals negative 30. Oh, and guys, this, in terms of this level of work, it does not get easier than this. So what we try to do is we try to see if between the two equations, if there is a variable which has two numbers with the same coefficient next to it but opposite signs. So we see for the x we have a 6 here and a 5 here, so that's not a really good match. But for y we have a 5 here and a 5 here. That's good. Not only is it good, it's great because if this is positive, this is negative. And the reason that is if we add these two equations together, we'll get 6 plus 5, that's going to equal 11x. Well, 5y minus 5y, that is going to give us 0. So we add these two things together. That's why they call it addition. But another reason it's called elimination is we eliminate the y in this when we add these two things together. Giving us 11x is equal to, let's see, negative 3 minus 30 is negative 33. Once we eliminate one of the variables, we get one equation, one variable, which we can solve, at least for the x value. So when we divide both sides by 11, we're going to get x is equal to negative 3. I'll show that down here. I think that work was not showing before. I'll go ahead and bring this up here a little bit. And like we did in the last class, if we want to want to solve for the value of y, we're going to take that value of x and we're going to put it into both equations and make sure that we get the same value of y. So I'm going to go ahead and put this into 6x plus 5y equals negative 3. And then we have 5x minus 5y equals negative 30. So we're going to go ahead and put x, negative 3, in for x here and here, and see that we get the same value y in both equations. So here we go. This is going to give us negative 18 here. Negative 18 plus 5y equals negative 3. Here we're going to have negative 15 here equals negative 5y. Minus 5y, not equals. This will equal negative 30. From here, if I move the 18 to the other side, that's going to give me 5y is equal to negative 3 plus 18. That'll give me 5y is equal to 15, because negative 3 plus 18 is 15. And just making sure I'm showing all this work here. Going to the top, here we go. If I divide both sides by 5, I should get y is equal to 3. So if negative 3 is a correct solution for x, I should get y is equal to 3 over here. So I'm going to move this negative 15 to the other side. So that's going to give me negative 5y is equal to negative 30, plus 15, because when I move this over here, I'm going to make it positive. And when I combine this, I get negative 5y equals negative 15. And if I divide both sides by negative 5, I should get y is equal to 3. So again, you're seeing a question like this. There's a fair amount of algebra here. And since we obtained the same solution for y, we can say that the set the solution set for this is going to be -3 for x and +3 for y. And that's going to be our answer for question 1 here. Just make sure when you're putting the solution in, you put it in as an ordered pair. If you won't do that, the computer will not like it when you're doing your homework. Let's go ahead and take a look at number 2 now, and let's see what we've obtained with this. So number 2, we have a situation where if we just add these together, we're not going to be able to have a variable be eliminated. So what we're going to do is we're going to go ahead and write this system again. This is going to be x plus 2y equals 6, and then we're going to have 4x plus 3y equals 4. So you recall that in the previous problem we manipulated, or in the previous section in 7.2, we manipulated one of the equations in such a way as to get the variable by itself, and that allowed us to do substitution. Here we're going to perform a different kind of manipulation for the equation. In this one, what we want to do, we want to have a situation like we had in the first problem where one of the variables, either x or y, in both equations have the same number next to it but opposite signs. Now you can achieve that with x or you can achieve that with y, but in this case the x is going to be simpler. If we wanted to, let's say, get this to have the same number, we'd have to multiply both equations by something. However, what we want to get up here, because we have a +4 here, the easiest thing to do is to go ahead and see if we can get a -4 next to the x, so that if we have a -4 here, we'll have the same number but opposite signs, so that when they add together, the x disappears. So we're going to figure out what can we multiply 1 by to get it to be equal to -4, and that's just going to simply be -4. So this first equation, I'm going to go ahead and multiply by a -4, and we're going to go ahead and rewrite this equation to see what we get. So -4 times x will be -4x. -4 times 2y will be -8y. And then -4 times 6 will be -24. This second equation here, I'm not going to change at all. I'm just going to go ahead and rewrite it down below. And now I'm going to add these two together. And in doing so, we're going to basically combine like terms. They're going to be right under each other in such a way that if we did our work correctly here, the x's should reduce to 0, and we add to eliminate, in this case, the x variable. So -4x plus 4x, that's going to equal 0. -8y plus 3y will be -5y. -24 plus 4 will be -20. And now, if I divide both sides by -5, making sure that this is showing here, yes it is, I show y is equal to +4. Now again, what I'm going to want to do here is I want to take this value of y, put into both original equations to make sure that we obtain the same value for x, so that we can be sure that the value of y we found for the solution is correct. So we're going to start with the equation x plus 2y equals 6, and then 4x plus 3y is equal to 4. So, by the way, this method works only if you're doing your algebra correctly, because if you're getting different results, it could mean that this value is not correct. It can also mean you made a mistake in one of these two. So always be cautious about that. So I'm going to go ahead and put 4 in place of y in both of these. So there'll be x plus 2 times 4 will equal 6. Then we have 4 times x plus 3 times 4 will equal 4. So give me x plus 8 is equal to 6. And this is going to be 4x plus 12 is equal to 4. So at this point here, I'm going to just move my 8 over to get x equals 6 minus 8, or x will equal -2. Again, let me kind of just, oh, that is showing. Excellent. Okay. I'll push this up a little bit because the other problem is going to be a little longer. If I move the 12 over, I'm going to have 4x equals 4 minus 12. That'll give me 4x equals -8. And if I divide both sides by 4, again, I'm going to get x is equal to -2. So I am reasonably sure that we've done the correct work there. So here's the work all together in its entirety. The last thing we want to do is just offer the solution set for problem 2, and that's going to be -2 and +4. -2 for x and +4 for y. So the solution to question 2 in the homework here is going to be -2 and then +4. Okay, at this point, now that you kind of see the level of work that's going to be involved, you may want to try question 3 on your own to see what you could do with it. You may want to just watch one more because the work of this can still be tricky. So if you want to watch one more to kind of get the gist of this, you may absolutely feel free to do so. But if you want to try this on your own too, you're also welcome to do that. Okay, so what we're going to do in this problem here is anticipating where I'm seeing this problem going. I think it's probably best don't try this one at this time. So not on your own at least, because we're going to see a few different types of solutions in questions 3 and 4 that you should probably see before you begin trying some of these on your own. So the first equation is going to be 4x plus 2y is equal to 0. The other equation is going to be 8x plus 4y equals 2. Now in both of these cases, it seems like you can either go after the x to try to get these to have equal but opposite signs or numbers, equal numbers but opposite signs, or you can go after the y and get this to be the equal numbers and opposite signs. So let's just let's go for the y this time. Let's just say to do that. So if I take 2 times -2, that's going to be -4. So I'm going to go ahead and multiply this entire equation by -2. What that's going to give me is going to give me -8x. It's going to give me -4y will equal 0. And the second equation I'm just going to bring over, 8x plus 4y equals 2, excuse me. Well, when I add this together, these drop out, just giving me 0, and I get 0 equals 2. In that kind of instance, just like in the previous 2 sections, when you have the variable drop out entirely, and you have 2 numbers that are not equal to each other, we like to say that there is no solution for this. And you don't have to go any further than that. You just may want to double check your math to make sure that you did that correctly. So for number 3, that's going to be a situation where there is no solution. Let's take a look at number 4 now. Let's see what happens in this case when we work on this problem. So this system is going to be -4x plus y is equal to 1. And then the other equation is 16x minus 4y equals -4. Well, let's see. The good thing is, at least on, let's say, the x's, we'll just go after the x's here. We have them opposite signs already, so I just need to figure out 4 times what is 16? 4 times 4. So I'll go ahead and just multiply this whole thing by 4, and let's see what happens once I do that. 4 times -4 will give me -16x. 4 times y will give me plus 4y. 4 times 1 will give me 4. Now I'm going to copy the bottom equation and bring it over here. Now if I add all these together, -16 plus 16, 0. Plus 4y minus 4y, 0. And then 4 minus 4, that's 0 too. So unlike problem 3, in this case, we have 0 on both sides. We have basically one side equaling the other side. So what's happening in this case, we basically have infinite number of solutions. Now we only have either no solution or infinite number of solutions when the variable drops out in the mathematical process. What separates one that has no solution versus one that has infinite number of solutions? For no solution, you're going to obtain 2 numbers not equal to each other. For an infinite number of solutions, you're going to obtain 2 numbers that will be equal to each other, and hopefully you know that 0 is equal to 0. Okay, let's go ahead and take a look at some more questions here. Now you've had a chance to see a few of those in action. Maybe a good opportunity for you to try some of these questions on your own before you see me do the work to these, and let's see how you focus on these. So if you do try this on your own, one word of advice, we'll probably want to have the x and the y on the same side of the equation. So you may want to change one of these. So if you make an attempt to do this before I show it, you're probably going to want to change one of these equations to get the x and y on the same side so that we can add everything, and I'll let you decide how you want to proceed. All right, we're going to go forward now then. So I'm probably going to readjust this equation here because I want this negative 11y to be on the opposite side of the equal sign. So I'm going to rewrite it with that being the case. So if I move it to the opposite side of the equal sign, I'm going to write it as 12x plus 11y equals 36. Now, for those people who are watching these videos who have not had me as an instructor, it's helpful to know that I've gone through the process of applying the additive inverse so that when we move terms from one side to the other, that it's an application of the additive inverse. In doing so, I just try to cut the work out of doing that to save on space and time. So my students understand that it is a process of, or an application of the additive inverse, and when we move things from one side to the other, we understand we need to switch the signs of those terms that we do move. The other one is going to be 3x plus 2y equals 9. So what we're going to do in this question now that we have the x's and y's on the same side, everything is nicely stacked on each other. We have the x's stacked, we have the y's stacked, the equal sign stacked, and the numbers here. You notice that everything here, you may look at these equations here and see these are written in standard form. So that's what we learned about in chapter 6. This is one place where standard form is somewhat useful, but not useful for graphing lines here, but it comes in handy for the addition method. So what I'm going to do for this one now is I need to pick a variable to eliminate. And I'm going to try to get one of the variables to have one pair of variables that have the same number but opposite signs. And I think probably the way to go is to take, because I can take 3 times 4 and get 12, but it has to be a negative 12 since it's going to be opposite in sign. So I'm going to multiply this through by negative 4. And in doing so, I'm going to get negative 12x minus 8y equals negative 36. On the top, I'm just going to rewrite the top here. 12x plus 11y equals 36. Now, be a little careful on this one because one thing you'll notice, it looks like we're going to get a couple of zeros out of this. This variable will be eliminated. Here we're going to get 3y, and here we're going to get 0. So in this problem, we still have a variable. And if we have that, if we divide both sides by 3, we'll get y equals 0. And that's a perfectly acceptable solution for y. Now that's not to say that we did everything correctly here and maybe I did some work wrong. But if we get this, we can still test this to see if it works in this system. So in order to test, see if that solution works in this system, I'm going to go ahead and I'm going to put down those two equations as they are originally written. So I'm not going to take and use the one I changed, from what I changed to. I'm going to use the original. So it's going to be 12x equals negative 11y plus 36. And the other equation will be 3x plus 2y is equal to 9. So I'm going to take the value of y equals 0 and put it in. So I have 12x equals negative 11 times 0 plus 36. And here I'm going to take 3x plus 2 times 0 equals 9. Once I multiply through by 0, you know that anything times 0 is 0. So that's going to give me 12x equals 36. This is going to be 0. So here we'll have 3x is equal to 9. And finally, if I take this, I divide both sides by 12 here. I get x is equal to 3. And over here, if I take both sides that I divided by 3, we have x equal to 3. And we obtain the same solution for x, so I think we can say with confidence that the solution to the system is going to be the point 3, 0. And that's going to be your answer for question 5. Let's go ahead and take a look now at question 6. Now, in question 6, this is going to be the first one we encounter where, well, let's just take a look. I don't encourage you to stop the video at this time unless you're feeling like you really want to stretch yourself, but let's go ahead and see how we tackle this one. So we have 3x plus 2y equals negative 10. The other equation is going to be 2x minus 3y equals negative 24. Now, we can't multiply 2 by any whole number to get it to be 3. So that means that we're really not going to be in the position to multiply any one equation by just one number and get the coefficients to match. So what's going to happen is, in this case, we're going to have to multiply both equations by something to get this to match. So let's just take a look at y. And the reason I'm looking at y and focusing on it is because even though they're not the same numbers, they do already have the opposite sign. And because of that, I could use that fact where I'm going to multiply both equations by a positive value so I don't have to worry about distributing the sign inaccurately. So when I do this now, I see that if I have 2 and 3, I know the least common multiple is 6. Another way to think about this too is if I have a 2 here and a 3 here, I know that 2 times 3 is going to get me 6. I know 3 times 2 is going to get me 6. So I'm going to multiply this top equation by 3 in order to get this to be positive 6. And I'm going to multiply the bottom equation by 2 to get it to be negative 6. So in this case, we're actually changing both equations now in order to try to simplify this problem and find a solution for it. So I'll put that there. Okay, so multiplying through, we get 3x times 3, that's 9x. 3 times 2y is going to be plus 6y. 3 times negative 10 equals negative 30. Here we have 2 times 2x, that's 4x. 2 times negative 3 is negative 6y. 2 times negative 24, that's going to be negative 48. Now I can add those together and you should see that the y is going to be eliminated from here. So we're going to have 9 plus 4, that's going to be 13x. That crosses out. And then 30 plus 48, that's going to be equal to negative 78. Now for this one you probably want your calculators, but if I take both sides and I divide it by 13, I'm going to have x is equal to negative 6. And at least for this, that's the solution I get for x. We're going to go ahead and want to check that now and see what solution we get for y. So I'm going to put that value of x equals negative 6 into both equations and see if I obtain the same value for y. Let's see. So I'm going to have 3x plus 2y equals negative 10. Then I'll have 2x minus 3y equals negative 24. So this is going to be 3 times negative 6 plus 2y equals negative 10. This is going to be 2 times negative 6 minus 3y equals negative 24. Well, let's do this. This will be negative 18 plus 2y equals negative 10. This will be negative 12 minus 3y equals negative 24. I'm going to just continue to solve each side now one at a time. I'm going to write this as 2y now equals negative 10. Moving this over, make this plus 18. 2y will equal 8. And if I divide both sides by 2, y is going to equal 4. Trying to make sure I'm showing all this work here. Here we go. In the last part here, I'm going to move this negative 12 over here. So that's going to be negative 3y equals negative 24 plus 12. Again, switching the signs here. That'll be negative 3y is equal to negative 12 when I combine. And if I divide both sides by negative 3, y is going to equal a negative 12 divided by negative 3 will be plus 4. So we have the same value y in both cases here. So we can say with confidence that the solution set for the system is going to be negative 6, positive 4. And that's question 6. So sometimes you may have to multiply both equations by a number in order to get the coefficients in front of one of the variables to be same, but the opposite sign. Okay, so bearing this in mind, we're going to go ahead and take a look at number 7 now. This may be a good point for you to stop your video and see if you can tackle this question or not here. So go ahead and stop the video if you want. Otherwise, I will take this question on and see what I can do with it. Okay, so We're going to go ahead and write this out. Let's see. We have 5 and we have 15. We have 4 and 12. Okay, I think I see where this one's going here. So if you take a look at this, you notice that 5 times 3 is 15. Negative 4 times 3 is negative 12. So if we do this, so let's just go ahead and take a look. I'm just going to, well, these are the same sign. These are the same sign. I'm going to go ahead and multiply this one by negative 3, and let's see what happens. So I'm going to take 5x minus 4y equals 5. And this will be 15x minus 12y equals 10. And I'm going to multiply this by negative 3. Remember, I have to get one of these to have opposite signs with this, and then be the same number. This will give me negative 15x. This will give me positive 12y. This will give me negative 15. Then I'm just going to write what I have below here. 15x minus 12y equals 10. Well, when we add these together here, these drop out, these drop out. That gives me 0 over here, and this could give me negative 5 here. So hopefully you remember that when you have two numbers and both variables drop out, this is going to be an example of a system that has no solution. And that's what you get for question 7. Let's take a look at how we handle a question like we have for number 8. And you're probably looking at this saying, gosh, those fractions look terrible. Yeah, they do. But, you know, so we're going to try to rewrite those to get rid of the fractions. I don't think you'll be getting anything on the final this scary, but if you do, you should know how to handle it. So for the first system, we're going to go ahead, we're going to have x minus y divided by 7 equals negative 1. And then your second system is negative x over 2 plus y over 16 equals 1/4. So I think probably you don't have to do it this way. You could do it another way. But I would just get rid of these fractions in the beginning and then worry about how I'm going to handle the system from here. So if I'm taking a look at the top equation, since I have a 7 in the bottom, I'm going to want to multiply the whole thing by 7. So 7 times x, that's going to give me 7x minus y divided by 7 times 7. The 7's cancel, leaving me with just y. And then negative 1 times 7 will be negative 7. So now we have this equation written here without a fraction. Next, we have 2, 16, and 4. Now, trying to multiply this out, I mean, you can make this really big if you want. I'm going to try and hope that you guys will understand that when we're multiplying this out, well, let's see. 16 you'll see is hopefully the least common denominator in this. So I'm going to multiply this through by 16 and see what we get. So if I have 16 divided by 2, that's going to be 8. So that's going to give me negative 8x. If I have plus y divided by 16, the 16 in the here and the 16 in the bottom cancel, give me plus y. Okay, and then finally here, 1/4 of 16 is equal to 4. And at least here, if you multiply by good numbers, once you get rid of the fractions in this, it turns out that if you add these together, the y's are going to cancel automatically. Not only do the y's cancel and leave like no y at all, you get 7 minus 8 giving me negative x equaling negative 3 when you work on this. So if negative x is equal to negative 3, we can divide by negative 1 to get x is equal to 3. And then once you're done with that, you can try plugging 3 into this now. Most of the time I would tell you to plug into the original equations. However, because of all the fractions involved, probably this is a good example where you may just want to plug into the equations that you manipulated together. You run the risk potentially of maybe not getting a right answer if you work with these wrong, but I know how people feel about fractions, so that's what I'm going with. So I'm going to write down the equations I have here. So 7x minus y equals negative 7, and then negative 8x plus y equals 4. I'll show what this looks like with the fractions here in a little bit. So if I put that in, that'll be 7 times 3 minus y equals negative 7. This will be negative 8 times 3 plus y is equal to 4. This is going to be 21 minus y equals negative 7. This will be negative 24 plus y equals 4. So if I move 21 over, that's going to give me negative y equals negative 7 minus 21. Here, y will equal 4 plus 24. Here, y will equal, move that up a little bit, 28. Here, negative y equals negative 28. Carry that out. I need to divide by negative 1. Y equals 28. So more than likely, it appears that our solution is going to be 3 and 28. Now we're going to do this by plugging this into the original fractions, and let's see the work involved. Now again, just to remind you that when you're doing this, and just kind of show all the work from here and then here, okay, there's the main body of the work, there's just that last step in the left corner. Doing this with fractions, you should be using your graphing, or your, not graphing calculator, but scientific calculator to help you along with this. So I'm going to show the substitution of the value of x equals 3 in with the fractions to see what this would look like if you're using a scientific calculator. So the original equations here again are going to be x minus y divided by 7 equals negative 1. And then the other equation is going to be negative x over 2 plus y over 16 equals 1 over 4. So let's say I go ahead and put 3 in for x. That's going to give me here, let me make sure everyone can see this. Yeah, right here. Okay. This will give me 3 minus y over 7 equals negative 1. Here I'm going to get 3 over 2 plus y over 16 equals 1/4. Well, one thing you may want to try to do that may make things just a little easier here, I can move the 3 over the opposite side, so that's going to be negative y over 7 equals negative 1 minus 3. Or it'll be negative y over 7 equals negative 4. Let's see if we can do the same thing over on this side. So I can rewrite y over 16 equals 1 over 4 plus 3 over 2, because when I move it to this side, I'm going to make this positive. And when I combine like terms, and again do this on your calculator, y over 16 is going to be equal to 7 over 4. Now at this point, you're probably going to want to try to clear the fractions out of this. And in this equation over here, you can go ahead and multiply this through by 7. And that's going to give you negative y, because the 7s will cancel here, will equal negative 24. And then if you divide by 1, negative 1, y equals 24. And you're done. And that yields the same result that, hold on, 28, excuse me. So 7, when I multiply 7 times 4, it'll be 28, not 24. So that's my mistake right there. So let me make sure that I caught that. Here, if I multiply through by the quantity of, let's say, 16 times 4, like I've taught in class, here the 16 cancels, leaving us with 4y. Here, the 4 cancels, leaving us with 16 times 7. And 16 times 7, I believe it's going to give us 112. And then if I have 4y is equal to 112, if I divide by 4, y will equal 28. So if you're wondering how to do that with the original problems, that's how that one would be done. And we did obtain the same value of y for both cases. Therefore, we can say pretty strongly that conclusion is correct. 2 more questions to attack your brain and refine what you can do with the addition method here. So make sure to stay with us. You're almost done. Let's go and take a look now at question 9. Now, this is similar to something else. There's probably something you need to do in this question before you go on. If you want to try this question, you can pause the video now. Otherwise, you can continue to watch, and we'll work through it. So in this system, it says that you can use the addition method or the substitution method. So you can use the addition method or the substitution method. Well, if you're looking at this system, if you were to choose the substitution method, you could, since y is equal to 4x minus 3, you would use the second equation to put it in the first. So I'm not going to work this one all the way through, but I am going to show you how to change this in order to make it work. So what I would do is I take the second equation, put it into the first. So my first equation is 2x minus 2y is equal to negative 6. Since I know y is equal to 4x minus 3, this would be 2x minus 2 times 4x minus 3 equals negative 6. And then I could solve that and get x. And then later go to get y. So what I'm doing here, let me kind of highlight this. This is the method by substitution. If I want to do this by addition, I need to take the original equation here, and I need to get the x on the left-hand side. So when I rewrite the system by, that's a really terrible grouping symbol. Here we go. It's still not great, but I'll live with it. If we want to move the x to the other side here, we're going to leave this as x because we have these in standard form. So there'll be 2x minus 2y equals negative 6. Then I'll move the 4x to the opposite side, giving me negative 4x plus y is equal to negative 3. So if we solve this with the addition method, we need to rewrite the equation to look just like this. And let's see what we get. So if we do this by substitution, actually I think I will work this out. You probably guys will want to see what this looks like. So let's go ahead and look at the substitution method. So I'm going to distribute negative 2 through here. That's going to give me negative 8x. This is going to be plus 6. I'm going to bring everything else down now. I'm going to move this positive 6 over. So 2x minus 8x, that'll be negative 6x. If I move, I should have moved this over first, but that'll equal what? Negative 6 minus 6, or negative 6x is equal to negative 12. If I divide both sides by negative 6, x will equal positive 2. Let's see if we can work out to eliminate y on this side, and let's see what we get if we do that. So I'm going to choose to eliminate y over here. What I'm going to do on this one is I'm going to multiply this equation by just 2. So that's going to give me here negative 8x plus 2y equals negative 6. And then at the top here, I'm just going to leave this as 2x minus 2y equals negative 6. And you'll see here, we're seeing some similar numbers emerge out of these two different methods. The y's disappear. We have 2 and negative 8, so that's going to be negative 6x equals negative 12, just like we got here. And if we make sure that everyone can see, ooh, I'm sorry guys, I didn't realize you couldn't see this over here. So let me talk about this again. I multiplied through this by negative 2 to get negative 8x plus 2y equals negative 6. Hopefully you can see that. 2 times negative 4x is negative 8x. 2 times y is 2y. 2 times negative 3 is negative 6. And then I just rewrote the top again. So when I add these together, these add the negative 6, these cancel, these add the negative 12. Then I'm going to divide by negative 6 to get x is equal to 2. From that point, I think you should be able to sub x into, you want to, again, sub it into the original equations for both of them to make sure that they work. And here, you want to sub x equals 2 into the original equations to check that they work also, whether you do it by addition or by substitution. I think I'm going to wrap it up here because my lunch is ending soon. So that is it for Chapter 7.3. You can try the last question on your own. See me in class if you have any questions. Thank you.